वेलकम बैक टू माय डियर फ्रेंड्स टू द टेक सिविल लर्निंग। आप सभी को टेक सिविल लर्निंग में स्वागत है। एज यू नो आवर चैनल इज कंटिन्यूसली इंसिस्टिंग विद प्रोवाइडिंग द प्रैक्टिकल एजुकेशंस टू द स्टूडेंट्स सो दैट the students can understand the concept very clearly, and I will try to connect you to the practicals levels. So without wasting time, let's start the today topic which is mentioned in the thumbnails. So my dear friends, I promised you, just give me your 20 to 30 minutes time. You will surely going to understand how to design a singly reinforced beam. If you really understand my concept, please don't forget to share it to your friends so that they can get help from you. So let's start. Okay my dear friends, today we will design a singly reinforced beam. We have already discussed about the singly reinforced beam. We have already analyzed the singly reinforced beam, right? In the previous video we have already seen the design steps which involve in designing the singly reinforced beam. So if you have not gone through that video, please go through so that you can understand the concept very clearly. So today we will particularly discuss about the solved numericals, or the means how to design a singly reinforced beam. So let's see. आई होप आप सभी को मीन्स क्लियर मीन्स अच्छे से पता होगा कि सिंगली रिइंफोर्स्ड बीम क्या होता है। तो चलिए आज सो हेयर मीन्स इन द क्वेश्चंस इट इज गिवन अ रेक्टेंगुलर बीम, राइट? वी हैव टू डिजाइन अ रेक्टेंगुलर simply supported beam, right? Means there are different types of beams, so we have to design a rectangular simply supported beam which is given supports of 230 width, right? Means this width is nothing but the means when the beam is given support, right? Means this, imagine this is simply supported beam, so the thickness of this one is nothing but the 230, right? Means thickness of wall क्या होता है? ये thickness of wall होता है, क्योंकि means simply supported beam is standing on the wall. So the clear span of the beam is 6 meters. So the clear span is 6 meters, and the beam is to have width of means 300 mm. Means here the width of the beam is given, that is 300 mm in the question itself. Whereas the characteristic imposed load, superimposed load is nothing but the live load is 12 kilonewton per meter. We have to design by taking M20 grade of concrete, where the steel says means a high yielding strength, that is Fe 415, and then design the beams. Where the in questions all the details are given, then we have to design the beam, and you know in the designs we will calculate, means we will go through step by step so that it's make you easy. हम लोग स्टेप बाय स्टेप जाएंगे, आसानी से समझ जाएंगे, ठीक है? मीन्स कोई खास नहीं है, आप ज़्यादा मीन्स जस्ट मीन्स कंसंट्रेट योर फोकस. Here I have written that is bearings, or the means support on the wall. Means the wall means the support which is given to the beam is nothing but the 230 mm. Similarly clear span is given 6 meters, so if you convert into mm, then 6000 mm means into thousands. Then live load is given LL 12 kilonewtons. Means characteristic strength of the concrete is FCK, that is M20 grade of concrete, so means 20 newton per mm square, where the means steel is used is, that is 415. So my dear friends, I have already discussed about the design steps involved in the means what you call singly reinforced beam. So we will follow the same step, means step by step we will follow the same steps which I have already discussed in the previous lecture. So we will follow the same steps, means step by step. So let's see the steps 1, right? In the steps 1 we will determine the dimension of the beam, right? First of all we need to determine means which dimension of the beam is perfect for the structures. So we will determine the dimension of the beams. For that means go to the means effective. In that ones first we will calculate the effective depth of the beam. उम्मीद करता हूँ कि आपको effective depth पता हो, ठीक है? अगर पता नहीं तो जाके पहले वीडियो देख लीजिए, मैं ऑलरेडी एक्सप्लेन कर चुका हूँ. सो हम लोग सबसे पहले फर्स्ट विल फाइंड द इफेक्टिव डेप्थ. इफेक्टिव डेप्थ इज दैट इज L/15. इट इज गिवन बाय द IS कोड बुक 456. So we can means in page number 36 it is given. So let's see the IS code book. This formula or this condition is given or taken from the IS code book. So from the IS code book you can see your code book IS 456, that the means L/15. Here the L is the means clear span, right? Means clear span, so it is 6000 by 15, so it comes 400, right? Means we have to assume the effective depth of the beam is means 400, right? Or means else you can go through these ones. I have already explained in the previous video that means for the simply supported beam the effective depth of the beam is from 1/12 to 1/15 of the span, right? Means you can take 1/13, right? Means that is means L/13. You can take L/14, right? Means L/15 you can take, but means up to L by in IS code book what it is mentioned that it is L by 20, right? Means greater than L by 20, we cannot assume that ones for the effective depth, as you can see from the code books. So from that ones it comes 400, or else you can go through these ones 1 by 12 or 2 1 by 15 up to 1 by 12 into 6000, or 1 by 15 into means 6000, then 500 to 600. So we have to take the smaller value. You can go through any two ones, right? This is formula where we means follow the means what we call IS 456 code book. So the effective depth of the beam is nothing but the 400 mm. We got the first value. So now we will calculate the overall depth. Okay, now we'll see the overall depth of the beams. My overall depth of the beam is nothing but the means clear depth plus means clear cover, right? Means suppose imagine this is a rectangular beam sections, right? If this is reinforcement, then overall depth is nothing but the means full depth. So full depth is, and F means verticals, and effective depth is up to means center of the steel bars to the topmost fibers. So that is means a small d plus D.D.R.C., right? Means that is effective depth plus clear span will give you means what we call overall depth. नाउ मीन्स आप लोगों का मन में सवाल मीन्स एराइज हो रहा होगा कि क्लियर स्पैन हम लोग को कितना लेना है, मीन्स हाउ मच क्लियर स्पैन्स वी नीड टू टेक. So my dear friends, don't worry, means either it may mention in the cover that means in which conditions we are going to design the structures, or if it is not mentioned, then please follow the IS code book means 457 page number 47. So let's see the IS means code books 456 page number 47, from where we'll get the clear span value. So let's see. Yes, as you can see here, so I have taken 456 means IS 456 2000s. My dear friends, here the nominal concrete cover, that is nothing but the clear covers, right? You can see for the mild steels it is 20, for moderate 30, for severs 45, for very severs 50, so extreme 75. So अगर क्वेश्चन में मेंशन कर दिया है कि we will going to design means structures means for the very severe conditions, then you can take. Otherwise, if it is not given, then you can take any value. So in our questions it is not given. So what I will do, I will take means I will design by taking clear cover as a 50, that is I will design in very severe conditions. So that's why I have taken 50 as a clear cover. So that's why means 400 plus 50, that is 450. So overall depth of the beam is 450, right? So now I will means in that ones I will means what you call calculate effective span. Effective span is nothing but the center to means the center to center of the support, right? Means later I will show you figures and I will describe all these things. So effective span is center to center of the support. So center means center to centers. Let's see here. Imagine this is beam, right? This is a beam. Here we have given a support of 230, right? That is wall thickness of 230, right? Suppose so clear span means center of here to here center, right? So already we have means what we call 6000, that is clear span, that is 6 meters clear span, and this one is 230 and this one is 230. So half of 230 and half of 230, 230 half, 230 half, right? And we will see that is center to center support. So we will take here up to means 230 divided by 2 plus 6000 plus 230 divided by 2, so 6 plus 0.23, right? Means 0.23, 6 plus 0, that is 6.23 meter is the effective span. So here the another method to calculate effective span is clear span plus means effective depth. So clear span is 6 and effective depth is 0.4, that is effective depth we have already calculated in the above means step means first, that is F means what we call effective depth is 400 mm. So in 400 mm it is 0.4 meters. So ultimately means what we call effective span is 6.4 meters. So in these two one we have to take a smaller value, right? Take the smaller value, that is smaller is 2.63. So we will consider the effective span of the beam is 2.63, and effective span is nothing but the center to center distance of the support, right? So we have already completed step 1. So let's see the steps 2. My dear friends, उम्मीद करता हूँ कि आपको स्टेप 1 समझ में आया. इन स्टेप 1 we have calculate effective depth, overall depth and effective span. Overall depth is nothing but the what we call means effective depth plus clear cover. So all these things I have explained very clearly. So in means step 2, as if you have seen my previous video, in steps 2 we will going to calculate the width of the beam, right? Because I am following the same procedures, same steps. So width of the beam is already given, so no need to calculate width of the beam. If it is not given, then I have already given in the design steps how to calculate the depth of the width of the beam. So we have to follow that procedure. So here it is already given, so no need to calculate. So similarly step 2 completed because it is already given in the question itself. Now we will determine the what equals design strength, that is mu, right? So mu, here mu limit will determines. In step 3 I have told you that we have to in step 3 we have to calculate limiting moment carrying capacity. Limiting moment carrying capacity is nothing but the maximum moment carrying capacity. So for carrying limiting moment of moment carrying capacity, we will apply the formula, that is 0.63 FCK BXU limit D minus 0.42 XU limit. So this this is the formula from where we will calculate the what you call limiting moment carrying capacity. Here 0.63 is 0.63 FCK is what you call characteristic strength of concrete, that is we will use M20 grade of concrete. So FCK is M 20. Here B is already given, width that is 30. Here XU is nothing but the what you call limiting of neutral limiting value of neutral axis. So it is not given, so we will write it as same. D is also D is already given, so we can write the D value, write 0.42 and XU. So here the unknown term is XU, so we will calculate XU, right? So my dear friends, XU value from the tables we will take that XU value for the different grade of steels, that is XU limit by D, that is effective depth is 0.53 for Fe250. So we are using here Fe415. So XU is not, XU limit is nothing but 0.48 into D. This D, if it is go, if we get XU by D is equal to this equation, then if you need to calculate XU, then D into, that is D goes this side, D into 0.48. So XU limit is equal to 0.48 into D. So 0.48 into 400, that it comes 192. So limiting of neutral axis is 192. So we'll just substitute this value in this one. So let's substitute and see what happens. So here 0.63 20 into 30, here the already what you call the XU limit is already 192. Similarly D is 400, that is effective depth 0.42 into 190. So ultimately it came 132.45 into 10 to the power 6 Newton mm. So if you would like to keep these units as usual, you can. So what I did, I just convert it into kilonewton per meters, kilonewton meters. So kilonewtons I will for converting Newton Newton into kilonewton divide by thousands, and mm into meter divide by 1000. So it comes 132.45 kilonewton meters. So hope you understands up to here, right? उम्मीद करता हूँ कि आपको यहाँ तक समझ में आया हो, ठीक है? Means you can calculate, that is means mu limit like this, or else you can also calculate mu limit 0.138 FCK BDA square. This is also formula from where you can calculate. My dear friends, here no need to worry about how can you remember this much formula. My dear friends, it is already given in the code book. Just what you need to do, you just need to follow your code book, right? Means all this formula is given in the code book itself. Up to now we have already completed up to what you call a step 3. So now we will see in we will step into step 4. So in step 4 we will design some moment, right? Because a flexure moment is always what you call affected by the moment first, then later it is affected by the shear. So we need to calculate the design moment, up to how much how much moment of resistance is produced by the our structures. So for calculating the moment, first we will calculate the self weight of the what you call concrete, right? So let's see, live load it is already given, that is 12 kilonewton per meters. So self weight, if it is self weight, that is Ws. If you need to calculate self weight, then this formula is B into D into density of concrete, right? This is the formula to calculate the self weight of the concrete, right? So B is nothing width of the beam, that is already given in the question 300, so 0.3, and D is nothing but the overall depth, because it is capital D, so 450, so 0.45 and 0.45 0.45 means per meter, right? It is given into 1 means per meter, right? So and this one means what you call density of the concrete is 25, right, as you know. So means ultimately it comes 3.375 kilonewton per meter. It is the self weight of the means concrete. So means for total load, that is W is equal to means live load plus means what you call means self weight. So means 12 plus 3.375, so ultimately it comes 15.375 is the total load, right? Total loads in the structures. So we need to calculate ultimate load. Ultimate load means maximum load, means इसको इस तरीके से समझते हैं, मीन्स जो भी स्ट्रक्चर्स है, मीन्स एनी स्ट्रक्चर्स अप टू हाउ मच लोड इट कैन विथस्टैंड, राइट? मीन्स आफ्टर बियॉन्ड ऑफ द अल्टीमेट लोड, इफ यू कीप मीन्स इंक्रीजिंग द लोड देन द स्ट्रक्चर फेल. इसका मीन्स अल्टीमेट लोड के बाद अगर हम लोग फिर से लोड उसमें लगाएंगे तो क्या हो जाएगा, स्ट्रक्चर फेल हो जाएगा, ठीक है. सो हम लोग अल्टीमेट लोड मीन्स जो लेते हैं वो सेफ्टी ऑफ फैक्टर को ध्यान में रख के मीन्स किया जाता है. So for calculating means ultimate load, we must have to consider the safety of factors. So safety of factor is nothing but for the concrete it is 1.5, and for means what you call steel is 1.15. So I have already explained all those things. So just means total means load into 1.5, that is means 23.0625. It is also called design load. So means we have already calculated means अल्टीमेट लोड जो है वो मीन्स इतना लोड मीन्स पर मीटर में इतना लोड मीन्स स्ट्रक्चर्स क्या कर सकता है, विथ स्टैंड कर सकता है, ठीक है. सो दिस इज द अल्टीमेट लोड. सो नाउ विल सी द डिजाइन मोमेंट, दैट इज एम यू. डिजाइन मोमेंट इज गिवन बाय WL²/8 as you know. So W is already given, that is WU 23.6 into that is here L is nothing but the effective length. Remember L is effective length, not the clear span. So effective length is 6.23 square into 8. So the design moment means value come 11.88 kilonewton meter. So this is the design steps. If and we have already calculated the MU limit and the MU. So my dear friends, if MU limit is greater than MU, then the design is safe, right? So the sections can be designed as a singly reinforced beam. If it is not, if MU limit is less than what you call MU, then we have to means increase the depth of the what beam, overall depth of the beam we have to increase, right? So that means it can satisfy this condition. So for the singly reinforced beam we must have to satisfy this condition. अगर ये satisfy नहीं होगा then we can't go for the further steps. So first we need to satisfy this condition. So here it is means our condition satisfied, that is MU limit is 111.88 and MU is, as you can see, MU how much it comes, MU is 132. So ultimately our condition satisfied, so we can go for further steps. So hence the section can be designed as a singly means reinforced beam. So up to unit what you call up to step 4 we have completed. So now we will see unit means step 5. So my dear friends, अगर अभी means आपको कोई means doubt है, then you can put your comment in the comment sections, and if you need any helps then you can contact us directly, which means I have already given the WhatsApp link in the description box. I have already substituted the means WhatsApp link in the description box so that we can contact us directly and we'll see the further actions. In steps 5 we will equate moment of resistance and the bending moment. In steps 5 we will especially calculate the area of steel. What? In steps 5 we will especially calculate AST. In steps AST, that we will especially calculate area of steels. For calculating AST we have to equate that the moment of resistance equal to bending moment, right? So means MU is equal to 0.87 Fy AST minus into 1 minus AST Fy B into D FCK. So my dear friends, this formula is already given in the means I have taken this formula from IS code book page number 96. So no need to worry, every formula will be given in the code book, and you means you have a right to take your code book to the exam hall so that you can means design or you can design the structure safely, right? So prefer page number 96, and from page number 96 I have taken that is MU is equal to 0.87 Fy AST into D 1 minus AST into Fy by BD into FCK. IS कोड बुक 456 का पेज नंबर 96 पलटाइए, वहाँ आपको ये फॉर्मूला मिल जाएगा मोमेंट ऑफ रेसिस्टेंस का और डी मीन्स डिजाइन मीन्स बेंडिंग मोमेंट का. ठीक है. You can take formula and you will substitute all these things. So mu we have already calculated, that is 11.88 into 10 to the power 6, that is we convert into Newton per Newton mm. So 0.87, Fy is 415 because we have used means 4 by 5 steels. AST you need to calculate, so you will substitute AST as usual. So D is already given, that is means effective depth, right, into 1 minus AST we will calculate, means B into D 300, means width of the vertical beam is 300 and the over means effective depth is 400. Similarly Fy is 415 and the FCK is M20 grade of concrete is applied. So here we need to calculate AST. So means by doing all these calculation, I hope means you can do these calculations. If you not, you just means you just bring 0.87 into 415 into 400 and bring that side and divide these equations means of this value, then we will substitute AST means 1 minus AST by means if you multiply 300 into 4 and all those things, it will come 5783.13. so multiply this AST in these terms, so ultimately you will get one quadrilateral equations, that is AST square minus 5783 AST plus 774.6. we will get these equations. You and from here you can solve means directly that AST value is 922 meter square, that is the area of the steel is 992. सो माय डियर फ्रेंड्स, अब हम लोग एरिया ऑफ स्टील निकाल लिए, लेकिन वास्तव में क्या ये एरिया ऑफ स्टील फिट है? कैन वी यूज दिस एरिया ऑफ स्टील्स इन रियल, राइट? सो वी हैव टू चेक ऑल दिस थिंग्स, राइट, मीन्स वेदर इट इज राइट और नॉट, मीन्स राइट, वी हैव टू चेक ऑल दिस थिंग्स. फॉर चेकिंग let's see. So this is the formula I have taken from means IS code book, or else means if you find any means solving means most of the students face means what you call difficult in solving the quadrilateral equation, right? So if you face the quadrilateral equation, my dear friends, then go through this formula, that is AST formula, direct this one, substitute all this value, you will get the same answers. आपको सेम आंसर मिलेगा. अगर आपको क्वाड्रेटिकल इक्वेशन सोल्व करने में कोई भी डिफिकल्टी आ रहा है, देन आप ये फॉर्मूला प्रोसीजर कीजिए, आपको सेम आएगा. सो चलिए, मीन्स वी हैव ऑलरेडी मीन्स गिवन दैट इज द एरिया ऑफ स्टील इज 922 mm स्क्वायर्स. सो लेट्स सी, मीन्स नाउ वी हैव टू मीन्स व्हिच मीन्स हाउ मेनी मीन्स व्हिच डायमीटर ऑफ बार वी विल गोइंग टू प्रोवाइड, ऑल डिपेंड अपॉन योर व्हाट यू कॉल स्ट्रक्चर्स, मीन्स किस टाइप का स्ट्रक्चर्स है उस हिसाब से हम लोग डिटरमाइन करते हैं. सो हेयर यू विल यूज 20 mm डाया ऑफ बार्स, राइट. In the all those things it is means using in the vertical tensile zone. So we will use 20 mm dia bars. So means a small AST is nothing but the area of one steel. Here 922 is the area of steel. Here we will calculate the area of one steel. So pi by 4 into d squares. So d is nothing but the 20. So area of one steel is this ones. So we have already means big AST and a small AST. So we will calculate means number of bar. So number of bar is capital AST by small AST. So we will get 2.96. So 2.96 means हम लोग को means इसमें number में then we will round off it to 3. That will provide 3 numbers of bar in the tension zone. हम लोग 3 बार रखेंगे टेंशन जोन में, ठीक है. सो विल प्रोवाइड 3 बार्स ऑफ 20 mm एट टेंशन साइड टू विथस्टैंड द टेंजाइल लोड. सो मीन्स ये हुआ थियोरेटिकल कंसेप्ट, बट फॉर द एक्चुअल लेट्स सी हियर इट द एग्जैक्ट वैल्यू इज 2.93, बट व्हाट वी डिड वी एज्यूम 3. सो द एक्चुअल एरिया ऑफ स्टील इज दैट इज एक्चुअल AST इज pi by 4 20 square into 3 because you have used 3 numbers of bar. So it is means what you call 942.8 mm square, right? And in the means above it is 922. So it is means so actual में जो वैल्यू आया वो 942 के करीब आया, और जो मीन्स हम लोग थियोरेटिकल वैल्यू है वो 922 है. सो हम लोग चेक करते हैं which value is whether the means this value is correct or not. So prefer page number 46 and 47 of IS code book. So let's see means page number 46 and 47. So let's see, my dear friends. So in page number 46 it is means tension reinforcement, right? Means tension reinforcement means what time means reinforcement in tensions. So minimum reinforcement, the minimum area of tension reinforcement shall not be less than that, right? Here now we'll go in what you call 46 page number, shall not be given by these ones, right? हम लोग को means we have got 2 AST value. So according to the IS 456 code books means the area of the steel should not be less than, that is AS by VD equal to 0.85 FY. So if you calculate AS, that is 0.85 FY into BD. So by calculating these ones, let's see how much value we will get, right? So from means the value should not means the value which will get from this equation should not be means should be the means what you call minimum area of what you call tension, right. सो इससे कम एरिया अगर हम मीन्स जो हमारा आंसर आया अगर इससे कम एरिया आ गया देन हम लोग समझेंगे मीन्स डिजाइन इज नॉट गुड, सो द डिजाइन कैन नॉट बी प्रीफर्ड. So from page number 46 and 47 AST that is minimum area of steels 0.85 by FY into BD, so we will get 4 means 246 mm square and we have means 942 and 922. It means we have already passed this criteria, right. Means it is means the value of AST which we got is more than means 246, means our design is safe, right. We have assumed the area of steel more than 246. Similarly now we will see the maximum AST, right. We have to means also show that the means what you call the area of steel should not be less than that. So means maximum for maximum AST means prefer page number 46 and 47. Let's see. I will means let's go to the IS code book. Here my dear friends, it is given as you can see here maximum reinforcement. The area of maximum tensile reinforcement shall not exceed means 4% of B into capital D. So we will substitute the value and we will check, right. So let's check. So if you substitute 0.04 into that is B is nothing but the 300, that means what you call width of the beam, and capital D is overall depth, that is 450. So it comes 4000 means 5400 and our area is means what you call our area of steel is 942. It means it is less than 5400, means that is actual AST is greater than means minimum AST. So design is okay or the design is safe. Our design follow the IS code book 456 page number 46 and 47. So we have almost completed half of the steps, right. So now we will see means what you call step 6. So my dear friends, उम्मीद करता हूँ अभी तक आपको step 5 तक means all doubt clear हो गया होगा. अगर कुछ भी डाउट है देन आप कमेंट बॉक्स में लिखिए, राइट. आई एम ऑलवेज रेडी टू सॉल्व योर डाउट. सो लेट्स सी means what you call step 6. So step C we will calculate the shear reinforcement, as the flexural member is always subjected to first bending then second shears. We have already means satisfying means all those bending designs. So let's see the shear reinforcement. My dear friends, for the shear reinforcement the maximum shears means occur at the support, right. So is equal to the means half of the total load, that is means this is also called shear factor, right. So the maximum shear we will calculate, that is W by means W into L by 2. So W is already means we have calculated, that is total load 2 means 23.0 means 0625 into that is effective means what you call span 6.23 by 2. So we will get that is 71.83 kilonewtons. So this is the means factors shears. So मीन्स वाई वी कैलकुलेट दिस वंस, हम लोग ये क्यों निकाले, बिकॉज इसका काम आगे लगने वाला है, ठीक. विल यूज दिस फार्मूला फॉर कैलकुलेटिंग द shear reinforcement. सो विल गोइंग टू यूज ऑल दोज फार्मूला. सो लेट्स सी, दैट इज preferred page number 72 IS code book 456. From there you will get formula, that is nominal shear means stress. Nominal shear stress means what you call the value of stress means beyond that the structures will fail. Shear means structure will fail means in shear means that is the means maximum shear stress which the structures can withstand. So let's see the page number 72. Here my friends, we are in page number 72. So it is given that as you can see the nominal shear stress tau v is equal to means vu by means bd. This is not, sorry, it is given wrong, mean that is b and d, right. It is not the base of b by d and the vu. So we will substitute this formula and we will calculate the nominal shear stress of the concrete, sorry, nominal shear stress of structures. So vu by b into d, that is 71.83. if it is in kilonewtons, I have taken this value kilonewtons. So if it is newtons into 10 to the power 3, that is b is 300 and this one, so tau v it comes 0.6 newton per m. So shear stress is 0.6 newton per mm. So we will calculate the percentage of tensile reinforcement, means again this will going to means we have usage of all those things for calculating the shear reinforcement. That's why we are calculating. हम लोग ये सब क्यों निकाल रहे हैं, क्योंकि ये सब का जरूरत आने मीन्स पढ़ने वाले है. सो उससे पहले हम लोग ये सब मीन्स सब चीज़ निकाल लेते हैं, ठीक है. सो विल कैलकुलेट द मीन्स टेंजाइल reinforcement percentage, that is small p is equal to AST by BD into 100%. So AST value is already we have calculated. So means AST is 942.8 and B 300 into 400 into that one, means the area of means what you call, sorry, the percentage of tensile stress is 0.784 percentage. So now we will to design the shear strength of concrete, that is tau c, means how much shear strength will concrete withstand. So we will prefer the right, means we will prefer page number 73 of table 19456 code number to calculating, that is what you call tau c. So let's see, dear friends, before that, before we'll calculate all these things, please remember this value, the percentage of tensile reinforcement. ये value याद रखिए हम लोग अभी will see the code book, that is 0.784, right? So remember this value. So let's see. Yes, we are in page number 73. So here as you can see, design of shear strength of concrete. So this one is percentage of this one represent percentage of tensile reinforcement, and this is the grade of concrete. So we are using M20 grade of concrete, where our value is 0.785. So let's see, 0.25, 0.5, 0.75 and 0.785, and directly it comes once, means our value lie between these, right? So our value lie between this means M20 is for 0.75 is means what you call 0.56, and for 1 is 0.62, but means exact value of 0.785 is not given. So we need exact value of, means we need to calculate exact percentage of steels, right? 0.75. so let's see, and we will use formula, just means from the code book, just means take this value, that is means area of, means what you call percentage of steel for means 0.75 is this, and for 1%, and it is for means 0.56, 0.62, and let's see. So here that is small p is equal to 0.75 and 1%, right? So here means the means what you call strength of concrete is means 0.56 Newton per mm, and it is for 1% is 0.62 mm. So we have to calculate means what you call for 0.784. So for means tau c 0.784 will means use interpolation methods. For interpolation methods, just what we need to do is means for calculating means what you call shear strength of concrete at 0.784 is equal to means 0.56, right? Means a small value of what you call a small value of shear strength of concrete, that is 0.56 plus, right, means a higher value of means what you call tau c, that is 0.62 minus a small value 0.56 divide by, right, 1, because here the means percentage is 1 minus 0.75, right? Hope you can understand that is 0.62 minus 0.56, 0.62, 0.56, 1 minus 0.75 into means we need to calculate 0.784. So 0.784 minus means a small, that is 0.75. So from here we will get means what you call the design strength of concrete, the design shear strength of concrete is 0.5685. So we will get the exact value of tau c. So hope आपको समझ में आया, hope you will get these steps very clearly. So if the tau v, that is nominal shear strength, is greater than means what you call means shear design strength of concrete, then means we have to design, right, means shear means we have to for withstanding the shear reinforcement, we have to design either stirrups or the means different criteria. So let's see page number 72 so that you can understand. So my dear friends, as you can see here, design of shear reinforcement, here it is what it is given. If tau v, that is nominal shear means stress, is greater means exceed tau c, right, then the shear reinforcement shall be provided any of the following forms, right? अगर नॉमिनल shear स्ट्रेस tau c से मीन्स ग्रेटर मीन्स बड़ा है, देन हम लोग को मीन्स ये मीन्स वर्टिकल मीन्स जो भी मीन्स रिइंफोर्समेंट है हम लोग को देना पड़ेगा, राइट? मीन्स आइदर वी प्रोवाइड द वर्टिकल स्टीरअप्स और बेंट अप बार along with the stirrups, right? We will provide all these things. So what we will going to means do in this numericals, we will provide the vertical stirrups. हम लोग क्या करेंगे इसमें vertical stirrups इसमें इस्तेमाल करने वाले. So let's see the vertical stirrups means we will provide the vertical stirrups. So here we shall provide the vertical stirrups, means we will not going to provide the bent up bar, we will provide the vertical stirrups. So shear resistance of concrete, that is Vc is equal to tau c into Bd. So from here means how much means shear resistance is offered by the concrete, we will get 68.22, right, kilonewtons. So here we will means design a vertical stirrups, right, for the shear to be carried out by the stirrups. Now we means stirrups, why stirrups is provided to means carrying the shear stress. So means vertical, that is V us, vertical means stirrups is nothing but the Vu minus Bc. right? So already we have calculated VU and VC, so it is 3.73 kilonewtons. So this is the means what you call shear strength which is carried by the stirrups. Means this much kilo means what you call load is carried by the stirrups, right? So let's designs means we will provide 8 mm dia means right. ये क्या है, ये चूड़ी का, राइट? चूड़ी मीन्स स्टीरप्स का डाया. चलिए मैं आपको एक फिगर दिखाता हूँ ताकि आपको समझने में आसानी हो जाए. विल प्रोवाइड 8 mm दैट इज 2-legged vertical stirrups, right? 2-legged vertical stirrups is nothing but, let's see the figure, you can understand clearly. Yes, आप जो देख रहे हो इमेज, ये जो चूड़ी है इसको मीन्स दिस रिंग इज नॉन एज स्टीरप्स इन द बीम, राइट? रिमेंबर what stirrups. So these stirrups is nothing but the 2-legged vertical stirrups. Had the 2-legged, that is 1 and 2, the 2-legged vertical stirrups. These stirrups is nothing but the 2-legged vertical stirrups. We have already designed these tensile steels, right? Means tensile steels. We have means already calculated 3 numbers of 20 mm diameter bar is provided, right? So we have already calculated, and now we will calculate the stirrups. So stirrups, in this the diameter of the stirrups is taken as 8 mm of 2-legged means vertical 2-legged vertical stirrups. So this is 2-legged vertical stirrups and this is nothing but the stirrups holders. My dear friends, मैं आपको पहले भी बोला था कि जो मीन्स वर्टिकल जो सिंगली रिइंफोर्स बीम होता है वो रियल में आपको कहीं देखने को नहीं मिलेगा, ठीक है? आपको मीन्स वर्टिकल कंप्रेसिव जोन में प्रोवाइड किया ही रहता है स्टील्स टू विथ स्टैंड और टू होल्ड द स्टीरप्स, राइट? सो वी कैनॉट मीन्स इट इज हाइपोथेटिकल्स मीन्स हाउ कैन यू means make a beam without means stirrups, and how can you means tie the means bond the what you call means steels without stirrups. So we need to provide these stirrups for the support, right? So means ultimately this is means what you call singly reinforced means what you call doubly reinforced beam. But here what happen in singly reinforced beam, these still act as a stirrup holder. So we will provide 8 mm diameter of stirrups. So for means area of stirrups is pi by 4 8 square into 2 because we will provide 2-legged stirrups. So it is means 100.53 mm squares. So now अब stirrups जो है वो कितना दूरी पे रखना है, ठीक है? एरिया ऑफ stirrups हम लोग निकाल लिए. अब मीन्स stirrups must be provided at the certain distance. Here you can see the distance, right? Means at what distance we will provide the means stirrups. So let's calculate the means distance of stirrup means spacing of means 2 LVS. It is given, this formula is given in page number 73. From that once I have collect this formula. So the spacing, right, vertical means stirrups spacing, it is 0.87 into Fy ASV into BD by SV. So we need to calculate the means spacing of vertical stirrups. So we'll just take it out. So SV is equal to means divided VSU. So ultimately it comes 3892.37 mm center to centers. But my dear friends, क्या ये जो आया है ये वैल्यू सही है या नहीं, ठीक है? हम लोग इसको चेक करेंगे, ठीक है? सो पेज नंबर 48 में जाइए IS कोड बुक को और चलिए देखते हैं वहाँ पे दिया हुआ है, ठीक है? तो पेज नंबर मीन्स कितना में 48 में हम लोग जाते हैं. Sorry my dear friends, I have not means captured the means font of page number 46, so, but you can see in your code books that is in page number means 48 it is given, so that is AS means ASBY B means what is BSB equal to means what you call 0. Means 4 divided by 0.87 Fy. So we need to calculate the spacing, that is SB. So ASB into 0.87 Fy into 0.4 into B. So it comes means 300 mm center to centers, that is minimum spacing, right? But in the means page number 48 it is said that means this one is the vertical wait my dear friends. So we have taken this formula from page number 48. So this is what you call means minimum space means minimum spacing, right? So here maximum spacing given by 0.87 into 2. This is also taken from IS code book page number 48. So it is 300 mm, right? So my dear friends, in any case आपको कोई भी केस में जो मीन्स क्या बोलते हैं स्टीरप्स का जो डिस्टेंस होगा वो 300 mm से ज़्यादा नहीं होना चाहिए. रिमेंबर इन माइंड वी मस्ट हैव टू कीप द स्टीरप्स डिस्टेंस नॉट मोर देन 300 mm, ठीक है? आप अगर डिज़ाइन कर रहे हो, अगर आप मीन्स इफ़ यू डिज़ाइन एनी स्ट्रक्चर्स ऑफ बीम then should not keep the stirrups distance greater than 300 mm. So we'll provide 8 mm diameter bar of 2 means vertical stirrups at the rate 300 mm center to center. So center to center stirrups का distance कितना रखेंगे 300 mm. So now up to here we'll calculate. Now what we need to check means whether it is satisfying for the deflection or not. इसमें deflection होगा या नहीं, means अगर मीन्स स्ट्रक्चर बनाने के बाद मीन्स ऑन द स्पॉट इट विल डिफ्लेक्ट और नॉट. सो वी हैव टू प्रिवेंट फॉर प्रिवेंटिंग मीन्स फ्रॉम प्रिवेंटिंग फ्रॉम डिफ्लेक्शंस वी हैव टू चेक मीन्स व्हाट यू कॉल डिफ्लेक्शंस. सो प्रीफर पेज नंबर्स 38, you will get the formula. So percentage of steel we have already calculated 0.784. So that is for the deflection. Fs is given formula, that is 0.87 Fy into AST required by, means AST provided. AST, this all we have calculated, 0.87 415. AST means required is, that is means 922, and AST means provided is 942, because this is the actual AST, right? So it means Fs means chems, that is means 232.46. we have taken this formula from page number 36, as you can see in your code book. As from here you can see F is 0.58 Fy, area of cross section of steel required and steel provided. From here I have taken this formula and I will substitute all this value, and let's see what we got. So कितना आया 235.46 Newton per mm square, right? So this is the value we got for means checking means deflections, preferred means chart for IS 456 for means modification. So means for satisfying these conditions, that is L by D maximums should not be means equal to 20 means into k the modification factors. So my dear friends, from where this k value is given means taken, right? So the main thing is from where this k value should be taken. So k value should be taken from the IS code book 456 page number how much, let's see once, page number what you call means 38. So let's see again the page number 38. Just remember this value 0 means 235.46 and 0.7845 means इस दोनों का बीच से जो रिलेशन आता है वो मॉडिफिकेशन फैक्टर से मीन्स डोनेट किया जाता है. तो चलिए IS कोड बुक में देखते हैं. नाउ माय डियर फ्रेंड्स, वी आर इन पेज नंबर 38. एज यू कैन सी द मॉडिफिकेशन फैक्टर, राइट? So you can easily see the modification factors, and the means here the different steel. So FC value is means 240, and our FC value is how much? It is already given in the questions. So we have to means it is greater than 190 and near to nearly means what equals 240. So we will consider 240. So in 240 this one is percentage of means reinforcement. So our is 0.785. So here's 0.7 will come up to here 0.4 and 0.8. So 0.75 will be of course in here. So we will go upward, right, and we will connect, that is 240. So means if you connect 240, right, here 240, right, because 240 is Fs value, right? So we can see here's how much means modification factor value comes 0.8 and 1.2 in between. So we will consider 1.1 as the modification factor. So from here we will take the modification factor value and we will substitute all this value in the above equation. So for satisfying the deflection conditions, L by D maximum equal to 20 into D. So L by D for maximum is means 6 means what equals L, as you know, means 6230 and divided by 4 means 400 equal to means 22. So it is means what equal, it is greater than, that is 20 into K, right? So L by max is means what you call greater than L by 8. L by max is greater than L by 8. So if L by D is greater than L by D max is greater than L by D, then there is a no chance of deflections taking place. ठीक है, तो यहाँ पे L by D max कितना आया 20 into K, that is 20 into 1.1, that is 22, and L by D कितना आया था 15.75. So जो L by D है वो मीन्स L by D max जो है वो L by D से बड़ा है, इसलिए यहाँ पे डिफ्लेक्शन होने का चांस ही नहीं, मीन्स डिफ्लेक्शन का क्राइटेरिया जो हमारा स्ट्रक्चर है वो पास कर रहा है. सो माय डियर फ्रेंड्स, वी हैव ऑलरेडी कंप्लीटेड ऑल द स्टेप्स ऑफ डिजाइनिंग द सिंगली रिइंफोर्स्ड बीम. नाउ इट्स टाइम टू डिजाइन मीन्स कीप दिस वन मीन्स पिक्चर्स. सो दिस वन इज वन रेक्टेंगुलर beam, overall depth is 450, this one's up to here effective depth it is nothing but the 400. So this one is a clear covers, right? So in a means what it calls in that compressive means zone will provide two means what you call two numbers of bars, that is sorry here 8 mm, it will provide two numbers means of 10 mm of diameter, right? will provide 10 mm of diameter. here हम लोग का ऊपर का बार मीन्स बार का जो डिजाइन है वो करना इसलिए नहीं पड़ा क्योंकि वो एज अ means stirrup holder का काम कर रहा है, right? So we'll assume we'll provide two number of bar, right, not more than one. We'll provide two number of bars in the compression zone to withhold the stirrups, right? So and in that means what you call in the tensile zone, right, as you can see in the tensile zone we'll provide three numbers of bars of 20 mm diameter, right? This is in tensile zone bar is known as main bar. So we'll provide this one stirrups, this one is nothing but the stirrups, and the stirrups is 8 mm diameter, two leg stirrups, center to center distance is 300, right? Means center to center distance is 300 mm, and this one's clear means span is 600, this one support is 230 and this one is 230, so total 6230. So this is the longitudinal view of our beam. If you see the top view, so this is in tensile zone will provide 3 bars, and means in the vertical compression zone will provide the 2 bars to withhold the stirrups, right? And overall depth is 450, effective depth is 400. So these bars already given, that is 20 mm of bar will provide 20 mm of bars of the 3 numbers, and this bar is of 10 mm diameter. So this is the procedures of designing singly reinforced beam. उम्मीद करता हूँ आपको समझ में आया हो, ठीक है। अगर कोई भी डाउट है, कुछ भी डाउट है, देन प्लीज डोंट फॉरगेट टू connect, without hesitations you can connect with us, so that we can solve your doubt, we can solve your doubt easily. So if you really like my video, please don't forget to share, subscribe and hit the bell icons, so that I will come with the different kinds of lectures. So thank you for watching my video. आप अपना ध्यान रखें और be happy all the times. Thank you.